Good afternoon, everyone, and thank you for joining our first session in our new Dukes 101 educational series. This series is designed to provide practical foundational knowledge for individuals who are either new to the wastewater, stormwater, or water infrastructure industry. It could be managers or other industry professionals looking to strengthen their understanding. It's really focused on the basics. You may have joined us in the past while some of our more technical webinars focused on advanced topics or emerging trends. This Educational 101 series really is focusing on core concepts that serve as the foundation of effective infrastructure management. Whether you're an engineer, project manager, utility professional, supervisor, or manager, our goal really is to provide informative content that helps expand the overall knowledge of our industry. I head up marketing at Dukes, and I'm honored to introduce our speaker today, and that is Mike Ping. Mike is the technical manager at Dukes and has over 23 years of extensive experience in our industry. He's a licensed professional engineer in North and South Carolina, graduated from Clemson University with a degree in electrical engineering. Today, Mike's going to provide an introductory overview of CCTV inspection and sewer cleaning, covering the basics of how these essential tools are used to evaluate conditions and support effective collection system maintenance. We encourage you throughout the session to use the Zoom Q&A to submit your questions, and we'll address all of the questions at the end of Mike's presentation. We'll also provide an opportunity, if we have enough time, to open it up live at the end. And what we'll need you to do is to just raise your hand and we'll unmute your mic. Once again, thanks for joining us today. And please welcome me please join me in welcoming Mike Ping.
Thank you, Mark. You hear me okay?
You're good.
Very good. All right. So yeah, this is pipe, CCTV, and cleaning. And again, as Mark stated, it's the very basics. So the agenda here, and this is kind of targeted for kind of the 30-minute range, but it's the very basics of a sewer system. Again, we're trying to hit, maybe young engineers, people new to the industry, and, not any without like hands-on experience, but we're going to be talking about pipe cleaning, kind of the why, how, a look at the equipment, and some real life scenarios. And then we're going to kind of at the end of that, have a little pop quiz. And if you notice at the bottom of your screen, there's a little chat icon. You can hit that. But when we get to it, I'll be sure and highlight it. But there's a chance to win a $50 Amazon card and some Dukes merchandise. I think we have hats and so forth, but just to try to introduce an element of fun here. So then we're going to move over to CCTV. So we're talking about a camera running through a pipe. Again, sort of similar. Equipment overview, how it works, and then a little bit of a dive into the results, kind of what those deliverables look like when a job's complete. And then we'll very briefly touch on some kind of advanced topics, including the role of AI, drones, and MSI. So jumping into it, kind of, if Dukes is a company, if you're not familiar with what we do, I just have one slide here to just sort of highlight that. But Dukes is a field service driven company. We got a small element of engineering going on, and some of these services are over here on the right listed out. Chemical root control, that's synonymous with the name Dukes. We do lots of monitoring. A lot of that is centered around what's called I&I, inflow and infiltration. And we certainly do lots of SSES, as it's called, and it's pipe. This topic is included pipe cleaning, pipe TV, and things like manhole inspections. Then we have programs. We do hydro excavation that's kind of centered around the lead and copper inventory initiative in the U.S. And then mainly in the western part of the U.S., we do trenchless sectional lining and top hats. All right, moving on to kind of the Sewer 101. I'll take just a few minutes here. This is a very basic concept, but, talking about a sanitary sewer system, beginning over on the left, you're talking about a user of water of some kind This is one of my favorite pictures in the industry that I've ever run across. It's a bathroom from Rome way back when, 500 BC. Very different uh, idea there going on compared with modern day. But be that as it may, there's the piping system goes out to what is would be called the public sanitary sewer collection system, and this is just a downward sloping. This one is an open channel, right? Today's sewers, so very similar, right? It's pretty much the same idea, except below ground, but it's conveying the wastewater discharge and off and away. In the original days, it would go directly to a body of water. In the 70s, the Clean Water Act was introduced in the USA. There's biological treatment plants that clean up the water and push the effluent out and it's cleaner water, right? So looking at the collection system, a modern day collection system, typically it's PVC pipe. A lot of times these days, especially in the smaller sizes, and this is an example of what it looks like there, sort of in the middle. Again, just a downward sloping pipe to be able to convey. No different than residential plumbing at a house, right? You can see there's an access point, the manhole, right, kind of centered around the three workers there, on and on to the wastewater treatment plant and to the receiving body. And then finally, kind of replacing the old Roman bathroom with modern day users of wastewater, restaurants, bottom left, industrial, residential homes, etc. They have a service laterals, it's called, goes out to the main sanitary, the public system, and goes all down, down the hill, so to speak, through manholes onto the wastewater treatment plant and through the to finally to the receiving water. So in the U.S., right, we have our own, and this kind of is, I hope, kind of ties in what the role of cleaning. So I use this example. I live in South Carolina. There's one of these systems in the Charleston, South Carolina area in the historical district. I know there are other very similar things in the older cities along the coast, kind of up and down the East Coast, especially the Northeast. But the piping network was built at an elevation that's kind of between low tide and high tide, right? So the users of wastewater, they're connected, and kind of how it would work. Well, here's a photo of one. That's a current photo of the one in Charleston. It's called the brick arch system, right? So that's literally a photo of the inside. And kind of how it would work is, beginning at low tide, the ocean would come up, would fill the system, right? At high tide, this man would come out of his little charming mansion over there, close the valve, right? Trap all the water in, let the ocean go to low tide, open it back up, and all this high velocity water that would be created would in effect clean the system. So cleaning was something that was thought of, part of the design from the very beginning in the wastewater collection systems in the US. All right, so we have our system here, very simple pipe. Generally, the design parameters are that this slope of pipe is such that it needs to create a certain a minimum velocity. A general design point is to create a velocity of 2 feet per second, so it's just nice and steady moving. A velocity of 0.001 feet per second, which is barely moving, is a problem, right? It'd be kind of a flat pipe, debris settle out, lots of cleaning to be done potentially, right? And then an access point, it's a manhole. Most times it's called a manhole these days, right? And the function of that is to just provide an access point to access the piping network that is below ground. So let's talk about what happens when there is debris in the pipe. So let's say we have some debris over here, and the wastewater network, there's no valving, right? It's free flow gravity. Nobody turns their sewer off at their house or industry or so forth. So the water's flowing just like that red arrow shows. If there's blockage, it just will back up, and we'll have what's called an SSO, and there will be, sanitary sewer water flowing in the road and the yard, wherever it goes to, right? So definitely not something that is desirable. And that's kind of what we're talking about here, cleaning to keep that from happening. And kind of while we have this drawing up here, another big emphasis in the industry is uh, identifying places of I&I or inflow and infiltration, which is essentially where rainwater is making its way into the sanitary sewer system. And at Duke's here, we spend a lot of our time doing I&I studies, different topics. I just wanted to mention it. Okay, one of the primary tools for cleaning pipe in the industry is what's called a combination truck. So this is a picture of one. These trucks come in all different shapes and sizes. They come in with different manufacturers of the vehicle. Like this one is a Sterling. You can see it on the front of the grill there. It could be a Freightliner. It could be other truck builders. And then the builders of the combination trucks, do their work and, fit out the chassis to be a combination truck. Now, let's talk about the names up there. Uh, you know, my kind of, since I joined the wastewater industry, it was always in my region called a vac truck, right? So you may hear it as a vac truck, you may hear it as a jet truck, you may hear jetter truck, you may hear combo truck, combination truck, whatever the case may be. It's the same vehicle, and it's there to serve two functions. It's there to clean pipe, number one, and then to get the debris out of the pipe into the truck and away, right? These trucks come in all different shapes and sizes, but functional wise, this is kind of represents probably the heart of the kind of the bell curve in most applications. This particular one is a small truck. Um, a lot of these are twin axles in the back and bigger and different tank sizes and so forth. So we'll take a look at kind of the key components of a vac truck, right? So beginning over on the left, you can see there's a water storage vessel. Obviously, if you're cleaning and jetting, you have to have source water. So this truck, typically would go to a fire hydrant, get permission from the utility, uh, pump some water into the tank. You can see there's a tank on each side. You can kind of look through the middle of the body there. You can see the inside of the other tank. So there's typically one on each side, right? And it's for the jetting system that's over here on the right. So this jetting system is very similar to a pressure washer, like from Lowe's, right? A pressure washer from Lowe's, the little two-wheeled one, typically jets at maybe 2 gallons per minute. It would be very normal for this truck to jet at 80 gallons per minute, right? So that hose probably, somewhere on the order of maybe 1,000 feet of hose. And as it gets used, it's going to get used. We'll see some pictures of it in use here. It gets hung up, it gets frayed. The operators will cut the hose, and it may end up going from 1,000 to 900 to 700. And at some point, you got to take all the hose off and buy a new hose. Then there's at the top here a vacuum system, and you can think of like a wet dry vac from one of the big box stores, Lowe's or Home Depot. Same principle, a lot more powerful. And over here on the right, or top left, there's a debris body. That's where all the debris that gets vacuumed out goes. And then there are the accessories here on the bottom that are, it's no different than a vacuum cleaner at the house. You have different attachments and so forth that would go here on the end of the vacuum system, so it can reach far down into a manhole. The manhole may be 20 foot deep. You have to have some extensions to get down there to vacuum debris out. But this is the workhorse of the industry for pipe cleaning and removal of debris. So kind of looking at this kind of homemade diagram that I made here, it's kind of a two-step process, right? So I often think of when I'm speaking with somebody that's never been around this, it's very similar in concept for me, at least, to explain it as like raking leaves across a lawn, right? If there are only a handful of leaves, maybe in one swipe, you can go from A to B and get all of them, right? If they're 2 inches of leaves, right? Probably you can't rake 200 feet all in one swipe. You maybe need to go out and rake 20 feet, get it back into the pile, go out 40 feet, get that back to the pile. And then, when you make that final 200-foot run which normally you're jetting up to the next manhole, sometimes further. But when you get to the maximum distance, it's hard to get the whole pile, and you maybe make several swipes of it, right? So the way that this works is this hose gets deployed into the manhole. You can see that the jetting action is going kind of backwards compared with a pressure washer, right? It's going back towards the hose, right? And that has enough force generated from the jetting to pull itself out. And as I said, typically it's going to go to the next manhole. And a lot of times the operators, there's usually two, they may pop the next manhole and look, and it goes on up, and he's waving to his colleague over there and saying, hey, the jetter's up here to the next one. And at that point, the controls are up here next to the reel, and the operator may hit the switch or do whatever mechanism, and it hydraulically pulls this line back, mechanically pulls, I should say. So it deploys sort of on its own. It gets pulled back by the hydraulics that are built in the reel system up here. So once the debris makes its way to the manhole, to the access point, the next step is to vacuum it out. So they get the vacuum system out. If there's a little pile there, like it's shown, easy peasy, vac it up, not unlike this kind of rigid, wet, dry vac, and voila, the debris goes into the tank. Right. So that's just a very simplistic kind of drawing of how this thing works. So some common limitations would be, number one, access. Let's say this big vac truck, again, this is a small one, right? So let's say this vac truck, you're in an off-road environment, especially on the East Coast where a lot of the systems follow a stream or a river, it can't get there, right? It cannot make its way to the manhole, right? There's other equipment, and I'll show some of that. Pipe conditions can limit the performance here. Roots, I mean, if there could be massive root balls, there could be offset joints that get the jetter head hung up, right? There could be protruding taps. There could be large debris volumes, right? So, if this is a 60-inch pipe and it's got, 3 feet of riprap size stone in it and bricks and so forth, then it's not a matter of like deploying the jetter and pulling it all down. There's too much volume. This vac truck could be sitting there for, weeks potentially, right? And then number 4, big flow. So if you could imagine a 60-inch pipe, right? And let's say there's 3 feet of flow, and let's say there's 4 inches of debris. You deploy the vac system, probably going to vac out a bunch of water. And then the debris body would be full, and the operators have to go dump, have to go to another manhole, dump that out. The exercise would be, it requires a different technique in big flow most times, right? But in a basic sense, this covers most of like pipe cleaning that's done kind of on a day-to-day level. All right, here's the pop quiz. All right, so if you would please if you mouse over the bottom of your screen, you'll see a little chat thing, and I'm going to pop up a question here, and it's just to kind of start to think about like debris, volumes of debris, and what they potentially can be built out to. No need for a calculator. Just I'm going to pop the question up. I'll read it. I'll give everybody 10 or 15 seconds to answer it. Whoever gets the closest number gets a $50 Amazon card. So don't worry. Just nobody's going to see your answer except Caitlin and Mark that are kind of running the webinar kind of behind the scenes here. So here goes. The question is this: how many 55-gallon drums of debris would be collected in a 2-mile section of 60-inch pipe if the debris is on average only 4 inches deep? So I have a little drawing there. How many 55-gallon drums? Again, just kind of gut thing, and I'm going to let this go for about 10 more seconds. Just pop it in the chat. You can put anything you want in there. I see 10. I see 9,000. So it spans the spectrum here. Somebody got very, very close. A couple people did. All right, we've got some good answers here. I'm going to let it go another 5 seconds here. All right, I'm going to hit the answer here. Caitlin, I think I saw a good answer there. Go by my screen. But So the answer is 807 55-gallon drums of debris. And if you look back at that and you're thinking, hey, 60-inch pipe, 4 inches of debris, whoop-de-doo, big deal. It's a huge exercise to get to remove that amount of debris. This could be a month-long project, $150,000 project, depending on other conditions, but it's not a, hey, let's send out the vac truck and vacuum for 2 days. It's not that exercise. That would be a big cleaning project. So another interesting way to look at the debris would be there would be over five, I think it's 5.1, 20-foot shipping containers full of debris. So that's a lot of debris, right? A lot of trips. That'd be maybe, 50, 60, 70 trips for, that vac truck that we had shown, maybe 40, 50, 60, depending on how the cleaning was going. Trips to decant, like dump the debris at a wastewater treatment plant, go get more water. It would be a huge exercise. So just trying to put some perspective on this. So here's a question. How much effort would it take to clean that same piece of pipe, that 2 miles, if it had no debris at all? Well, not much effort because there is none, right? What if it's unknown, right? So what if a utility manager, hey, well, let's clean the pipe. Look, those two scenarios are wildly different, right? Quite often, it's not uncommon to see a bid come out and it's like, hey, clean the 60-inch pipe. Nobody has any idea of how much debris is there. Well, if there's none, then it's pretty easy to clean, right? If it's got 2 feet in it, it could be $200 a foot, right? So just something to kind of think about. So if you're a college football fan, you may find this interesting. This is right on the building to the right is the University of Georgia football stadium. This is an example of very easy access. The 3 operators over there to the right, they pulled right up to the manhole. So they deploy the hose out and clean. They're cleaning immediately, right? Very easy access. Here's kind of the opposite end of the spectrum, right? Same diameter. Both of these are small diameter pipe. I think they're both, at kind of 12-inch range. In this scenario, the vac truck, I kind of refer to it as a vac truck. I think technically speaking, I should be saying combo truck or combination truck, but the vac truck, the vehicle that we were speaking about, it was about 1,000 feet off to the left. You can see an operator pulling hose, right, a long ways. He's hooking it up to the easement machine, which an easement machine, and I've got a picture coming up, in effect is a hose extender, kind of similar to a garden hose, hooking up an extra garden hose to reach further out in your yard. Then there was a small river, kind of a creek river, and then the sewer system was on the other side. So we got trucks, trailers, easement machines hauling all of this, qualified people to run it. Very different level of effort to clean pipe in this compared with the UGA football stadium. So here's some interesting pictures. I'll begin in the bottom left. So that's a little bit better picture of an easement machine. Again, you can see the black hose is from the truck that's parked, some distance away, probably within 1,000 feet. And this is a hose extender that's getting extended out. It's doing the jetting, and it's got the hydraulic system to pull or rake the debris back to the manhole. That's a mechanical feature. It goes out on its own because of the jetting action, and then it gets pulled back mechanically to get the debris back. And you may have to go, maybe one time is enough. It may require, lots of times. Typically in our industry, again, kind of normal to talk about 3 full passes being included in light cleaning, right? So anything more than 3 passes is generally classified as getting into heavy cleaning and usually hits a different line item. So if you're looking at this, it's off-road, right? There's an easement machine. If you go over to the right picture, they can't get the vac truck there, so this guy has to get in the manhole, right, and physically shovel it out. He's hooked up. It's confined space, a lot of safety gear, tripod, all that sort of thing. And you can see it in the top picture even. So he's shoveling, he's bucketing it out, 1 5-gallon bucket at a time. You can see these are all 3 pictures of the same application. You can see the picture in the middle. He's handing the bucket to his colleague there. He's dumping it into this little utility trailer. They've got a tracked piece of equipment to haul it out to the vac truck, and they suck it up into the vac truck and haul it away, right? Lot of work going on here. This is a very different application than pulling the truck up and just jetting directly. So, yeah, this is a picture on the left of what debris looks like. It always is a little bit different, but this is, looks like little gravel, sand, bricks, whatever. This is a photo from that same job. They found at the top there a driver's license from 1941, and it's very common for the guys to find lots of jewelry, right? So they collect it up, take it to the pawn shop, and cash it in and split it up or whatever. That's not an uncommon thing in the industry. But lots of things get found. This same job, I remember there was one section that was full of marbles, right? Little children's like glass marbles or whatever. So they had a whole trailer of marbles. So you never know what you're going to find. Okay, switching gears here. Bucket machine. These are not near as common as the vac truck. This is kind of for big pipe cleaning. Basically, it's a mechanical way to launch on one end, kind of the right in this picture, a bucket, and just mechanically pull it through. The bucket comes up the adjacent manhole on the left, and it empties it out into a container. These are pretty uncommon. I just wanted to mention it. It is it still happens, but it's referred to as a bucket machine. So kind of concluding here, the cleaning, we often, my work history, you often get a phone call. Hey, can you come clean this pipe? Well, as you can see, lots of questions. It can vary wildly. One of my favorites is this top right picture. I got, hey, can you come clean the pipe? It's like, okay, well, it's stormwater. Okay, well, that's a little different. And then can you send me a picture of it? And I get this picture here, and there's boulders and what looks to be 3 or probably 2 feet of sand. And so, I mean, that's a month to 2 month job, hundreds of thousands of dollars. Bottom right picture, you can see, there's a jetter truck with a extra large jetter reel with twin nozzles for high capacity jetting. This blue truck is a in-house developed specialty cleaning truck that can jet at 500 gallons per minute for, big pipe, big debris. And bottom left, sometimes you need to take the sewer offline and bypass pump so there's no water so you can get the debris out. So lots of considerations here, trucks, trailers, there's a lot that goes into the cost, traffic, road. And the biggest one down there, how much debris is there? None or a lot? Where is it? So forth. Okay, so switching gears here, we'll hit on CCTV, just some example pictures of cameras that traverse through the pipe. So the reasons that CCTV happens is, number one, to determine the pipe condition, find failures, prioritize upgrades. If you do the math, utility can't TV and clean their whole system every year. It's just cost prohibitive. All right. So you're trying to TV, find the worst areas and deal with those kind of as a priority. TV can accumulate the data can accumulate very quickly, and you need a dynamic system versus a static system. And most modern days, there's a software package that's built by the manufacturer and that houses all the data, and you're in kind of a GIS type environment. And but you need a system to retrieve and update the videos and catalog all of that stuff. And bullet point number 4 is this TV is a great time to correct GIS, the mapping of a collection system. If the camera goes in one manhole and it comes out, or you see it in the other, it is connected. You know it for sure. So a glimpse at the workflow. I kind of made this, and it starts in the top right. But the initial thing is to kind of review the job, scope it, plan it out. You've got a map here. Then you go over to the bottom left. The guys are out there. That's an off-road camera setup. they're out there, they're collecting the video data, and then from there it generally goes into an office environment, and there's kind of one of two ways. The defect coding and assembly of the deliverable could be kind of in the office. I mean, at Dukes, we do some of that hands-on, but we also use the AI that's becoming more prevalent in the industry. This is one example. We use a company called Sewer AI, where you just basically push all the videos into their portal, and then they produce the contents that we're about to talk about. So summarizing, doing the defect coding, and assembling all that information. And there is a lot of information that gets spun out of this. It's important to note this association called NASCO. It's the National Association of Sewer Service Companies. And for pipe, there's what's called a PACP, Pipeline Assessment Certification Program. It's a standardized system for coding and assessing pipe, and it ensures that utilities, engineers, really anybody in the industry can do, they're operating off kind of the same page of music, and can communicate and collaborate in a the same manner, so that so all the data shows up and can be transferred seamlessly. So a big part of that, just to hit one highlight of many here, is coding defects, right? I mean, cameras are looking at pipe, they're looking for issues. Here's one example. The scoring system is 1 to 5. 5 is the most severe. So you can see a photo clip. That's from a video, clipped out from a video. And every pipe segment receives a 4-digit score. So you see the defect, it gets a score of somewhere between 1 and 5, right? And then all those scores are aggregated. So here's an example. So for an example piece segment of pipe, it could be 5342 is the total score. And the way that it works is the first two, the 5 and the 3, go together, the 4 and the 2 go together, and the first two, the 3, there's 3 defects that are ranked as a 5, and then the second two, there's 2 defects that are categorized as a severity of 4. Right, so there's 3 defects that are the most severe. There's 2 defects that are the next most severe that are 4. So that's one example. Another example could be, and I just wanted to include this, 3A, 2B, which we in the English language use a base 10 number system. So after you go to 9, you have to use some other kind of thing. So you go to letters, right? So 3A would be that there are 10 defects ranked as a 3, and B would equate to 11. And sometimes these guys go all the way up to Z, right? I've seen Z defects, which is a lot. Normally, if you see Z, it's like you're talking about, hey, we need to dig up the whole pipe and put a new one in, or maybe potentially line it. All right, so quick snapshot of the deliverables, and then we'll conclude here. So this is a snapshot from our system, or a real project. We have the key elements. There's really 3 key kind of elements to it. The reports. So there's a report generated by the software or by the AI mechanism that's a unique report for one pipe segment, right? So you could print this, hand it to a contractor, an operator, and say, hey, we need to do A, B, or C, right? Now, this is just one page of the report. Normally, it's 3-4 pages, and there's photos of the defects and so forth, but it's one report per segment. So, of course, there's going to be at least one video per segment. Usually, you run downstream most times, not don't have to, but usually the way that it works is like the TV and the cleaning are operating in tandem, and the cleaning guys are pulling the camera down, and the camera guys are 10 feet behind it. Now, that's in perfect land. It doesn't always happen like that, right? So, but you have a video. These days, these videos are MP4 formatted, so I could email one to everybody on this call. You should be able to open it and watch it no different than a video, and it would look something like this. The next of the 3 key pieces is what's called this PACP database. And we run into this often where, there are people that operate in a database environment every single day. They're super fluent with it. And then there are people that look at this and thinking like, oh, I know what that is. That's Excel. This is not an Excel spreadsheet. This is a database. And just to kind of hit on it, I just wanted to anybody listening to be aware of this. I mean, a database operates very differently than Excel. There's a list of tables. We're looking at one table here, about three-quarters way down, that we're looking at the conditions table, right? And these are all linked up and together, but this is like all of the data from the project is included in this file. All right, so some of the equipment, this is a look, the vehicles kind of span the spectrum. The average vehicle is something like this. It's a van, has all of the TV equipment. If I open the side door that we're looking at, then you're looking at like what looks like a little office, right? Monitor, a desk, air conditioning. You know, this guy has the good out in the field. He's got it made. If it's hot outside, the doors are closed. It's dark. There's AC going. He's just looking at the camera view and the monitor. And usually they have a walkie-talkie or a speaker system to communicate. And then there will be a door. And if I open the back door, you'd see the camera system. All right. If you kind of squint and look up in the back of the van, you could see a window where these guys could see each other. Usually the guy running the camera, sitting in the office, is kind of the group leader in a lot of cases, and he's looking outside, just observing what's going on. But the camera system is on the left. See a little garden hose on the right. Usually there's a water source, and they can spray the equipment as it comes out. But it's got a reel. Camera goes out, launches in the manhole. There's a crane to help carry it. The cameras are heavy. There's all different shapes and sizes and so forth. So again, the camera systems are usually they can be in an off-road setup. That van can't go everywhere, right? So quite often in that easement that we were looking at the jewelry and so forth, this type of equipment would need to be utilized. So what are some of the challenges? This one on the left, I'll start there. The camera system drove down the pipe. You can see it. It's exposed. The pipe was in terrible condition, and it gets in an area, and there's a void underneath the pipe, and there's a hole, and basically the camera gets driven off into the open abyss, right? It's stuck. They're trying to get it out. You can't get it out, so you have to dig it up. It's a big problem. You're in a residential area. You got a mature tree there that you probably killed. You have to pour concrete. Lots of going on there, right? A lot of contingency happening. Meanwhile, the camera's in the pipe, potentially causing debris, maybe even causing a backup, right? Kind of a similar situation over here on the right, except it's in a different location. It's in the middle of a 4-lane road in a city. And some pictures from that, they have to cut it open, similar exercise. A very high-end camera that has lateral launch, a camera that's made has a camera that can exit the primary vehicle and go up a lateral to TV a lateral. And then finally over there on the right, you kind of see kind of the point repair where the pipe had to be repaired, all back, asphalt back to the transportation agency standards and so forth. Yeah, it's a big exercise. So we'll talk about MSI. MSI is an acronym for multi-sensor inspection. This is for bigger pipe, generally in the 30, 36 and up. Much more sophisticated platform and much more sophisticated deliverable. Usually these are including like the TV that we talked about. In addition to that, sonar for kind of below, kind of the fish finder to measure the debris quantities. LiDAR, which is in effect like a spray of survey grade location. It's in effect like surveying the position of the pipe. And then laser, which is like measuring. So, if the pipe ID should be 60 inches and the laser data comes back and it's 64, well, then 2 inches is gone of the pipe all the way around. 2 inches on each side would be, -4. So just a couple of, peeks at what this, these deliverables are, there's a lot more complex content. So there's calculating the debris. We talked about that earlier. Pipe wall thickness loss. And then the LiDAR, if you look at the picture on the left, potentially that, the camera operator could miss that. I mean, that's a very subtle defect. The LiDAR it's very bold, right? So there's a value with the higher end setup. It's a major crack here. Some more pictures of what that can look like. But LiDAR is essentially building up an XYZ point cloud. Okay, couple more slides here. Dukes. So there's some new hardware that's been introduced to the marketplace. Drones that can fly through the pipe. Right. It's very interesting. The deliverables that get spun out of this, super interesting. Really high quality. We have a system, and talking to some of the operations guys, like they're really impressed with it. So very good results. Good for stormwater. Good for sanitary. But in effect, you're talking about a drone that's flying down the pipe with all sorts of gadgets, LiDAR, cameras, this, that, the full suite. So very interesting and new. This is not, there's probably not many people doing this in the US, probably just a handful. Right. So one of the last slides here. So one is a concept when TVing is happening, right? It's very critical for this data to be linked up, properly linked up. One being area photos. There's an operator, at each manhole typically, right? And things like a basic photo can help in the future, right? Like it's a great example. This is a project that I worked on, right? Swimming pool in an apartment complex, and there's a deck, and of course everybody's looking for the manhole. We cannot find it, and it's under the deck, right? Really, really close to a swimming pool, right? It kind of goes lengthwise with the pool, right? So obviously there's a lot of value in this picture, but that value, there's no value if it's on somebody's phone and then transferred to Johnny's computer, and that computer ages out, and it's got to be linked up in the data warehouse. And the second bullet point there, I like to promote the idea of TV activity should always have a component in the workflow to correct the map. We ingest all of the projects. We always begin with a GIS, some kind of map file, a shape file of the project area. And a lot of people with good maps, nobody is making a 100, right? So as these activities are happening, it's a perfect time, TVing and cleaning, to, if there's a discrepancy in the mapping, to note that and to get it corrected. All right. So there is a QR code there that's active. You can scan it if you would like an attendance certificate. And I'd just like to note that the next in the 101 series, we kind of have a technical series going in this 101 series. I hope it was valuable for some of you. The next one is going to come up in about 2 months, and it's going to be CMOM, SSES, and SSO, kind of an introductory level explanation of the alphabet soup of the industry. So appreciate everybody's time and attention. And Mark, I'm going to head it over to you.
Thanks, Mike. We do have a few questions that I want to bring up and cover, and then also we have an individual. It's got his hand raised, so we'll open it at the end. But here's one of the questions, Mike. Once debris is removed from the pipe, where can we take where can the material typically be disposed of?
Yeah, very good question. I would say the most common would be at the wastewater treatment plant, kind of at the headworks, the front end of the plant. Quite often they'll have what's called a drying bed where debris can be there, and like the water drains out, that water drains into the treatment area. But the debris that comes out cannot be dumped on the ground. It's got a level classification that it's got to go to a certified wastewater treatment facility or a designated place by the utility. The utility owns the debris.
Thanks, Mike. Here's another question. Does Dukes use granite?
We do. So as a service provider, and probably all service providers, we have to be fluent in all software packages, right? So I can think of one kind of client, they have a granite system, so we need to use granite. I can think of another one that uses a package called IT pipes. So we use that. There are others, right? Some, there are other brands. There's probably, half a dozen primary brands of software. Same with hardware.
Okay, Mike, here's another one. What is the smallest pipe size available for using the drone system? How does this cost compare to other methods? Is the drone data easily transferable, or is additional software required?
Yeah, so it produces a 360 video file that I'm pretty sure is an MP4. So you ought to be able to get the file and see. It has its own, kind of like the other software. It has its own package, and my understanding is that, there's kind of the manufacturers. They want to say that they can go in super small pipe. I can check and follow up, but I think it's in that 36 inch range is generally considered small. The drone package itself, it's bigger than a basketball, kind of like a beach ball, I guess. So, it has to physically fit. So even if you have a 60-inch pipe and there's 5 inches of flow, it can't traverse through. So it's got to have a certain amount of space, but it has been, the group that operates it on our side has been very impressed with the performance. It's exceeded expectations.
All right, Mike, another one. There was a follow-up question on the disposal. We maintain all screenings and debris on site in a drying bed, then haul off to landfills half 1 to 2 times a year as hazardous waste. Costs are associated, but a method for disposal.
Yeah, I mean that's kind of the standard, right?
Yeah,
So, um,
yeah,
yeah, so you can, that stuff can go to a landfill. I kind of
yeah,
left that part out earlier. Ultimately, it gets to a landfill.
yeah,
The effluent out of a wastewater treatment plant is water that's going to the river. The solids end up in a landfill.
yeah. And Mike, and then I'll answer one of the questions because everybody's asking as far as will they be able to have they missed the initial part of the webinar. A recording will be available on our website, and it's also Caitlin put that into the chat. But there was another follow-up question, Mike, on how does the drone maintain a signal without a cable connection, and
Yeah,
what is its range underground?
I don't know the exact number, but it's an impressive number. So the intent here, like we're thinking about doing a more technical webinar on the drone. We've got some footage, so I apologize. I don't know the number, Mark. If you note that person's email, we can follow up with some better content. But it certainly can go out a good ways.
Great.
It's not 10 feet or 20 feet. It's hundreds of feet.
And then Robert Gravetti has his hand raised. So Caitlin, if Robert still has a question, um, if you want to unmute yourself, Caitlin is providing you. If you still have a question, Robert, want to give you an opportunity to ask that question live. Robert? Maybe not. Maybe Robert might have dropped. Oh, he said it was answered. We're good, Mike. Um, with that, I think we're gonna close up the session unless there's anyone else that wants to request or ask a question live. Just raise your hand. We'll wait a few minutes, and then we'll wrap things up and meet the time frame that we committed to you.
Yeah. And we'll also be in touch with the winner. There were a couple of very close numbers on the 55-gallon drum question. So one person is going to get some Duke's gear and a $50 card.
Yep. Okay. Thanks, Mike. Appreciate you putting this material together. Once again, For everyone, this is our first and what we hoped to be is multiple education series 101. I do want to do a bit of a public service announcement on behalf of the EPA. I just wanted to make sure everyone was aware that the EPA offers about a $10.8 million fund to train and with the hopes of retaining water sector workers. So it's available for public works departments, community colleges, universities, and other organizations can apply for grants from the EPA to train and retain workers in our industry. So that this is a workforce development grant, and they'll fund apprenticeships, school programs, employee partnerships, and applications are due October 5th. So just wanted to make sure you were aware of that funding. It's targeted towards our industry and making sure that we retain and grow the skill set and the education of the team. And with that, on behalf of Mike and Caitlin, we wanted to express our appreciation for you spending an hour with us and wish you the best. And hopefully you'll attend the next one, which is Alphabet Soup, an introductory level to all the acronyms that are used in our industry. Thanks, everyone. Have a great day.
Thanks, Mark.